So this is our second big idea. Our first big idea was just in general what a sequence is, right? List of numbers following a pattern, and we looked at some examples, looked at some general rules, figured out how to generate them. I did decide to make the figuring out the rule from the list of numbers an extension, so you'll see that in the extension slides following this. So keep that in mind. The second big idea that I want to talk about is something called a recursive sequence. So we'll see what that is. This is a really famous example of what we call a recursive sequence. This pattern is 1, 1, 2, 3, 5, 8, 13, and so on. And it's a really special sequence of numbers. It's a really famous one. We talked about this in the first week of school, actually. This is what's called the Fibonacci sequence. And the pattern is you add these to obtain this number, right? You add these two to obtain the next number, and so on. You add these two to obtain the next number, and it keeps going. So the idea is to get a term, you have to add the two terms right before it. And this sequence of numbers, these numbers actually come up so frequently in nature. A lot of times in flowers is a really common thing. We saw this at the beginning of the year, right? Flowers that have petals in these Fibonacci numbers. So like the columbine has 5, for example. The bloodroot has 1, 2, 3, 4, 5, 6, it looks like 8. And then black-eyed Susans, daisies often have petals in terms of 21. Right, here's a good example of a daisy with 21 petals. If you also look at spirals of pineapples, the number of spirals going in different directions will be Fibonacci numbers as well. It's really cool. Same thing happens with pine cones too. So, lots of different Fibonacci numbers come up in nature, which is super interesting. And so the Fibonacci number, or the Fibonacci sequence, is a sequence that we can write using an idea of a recursive definition. So this is what's called a recursive sequence. This is the second big idea. And don't feel like you have to write all this stuff down. I just found this online and I thought it was a really good way of explaining it. So it says the process of recursion can be thought of as climbing a ladder. To get to the third rung, you have to step on the second rung. Each rung on the ladder depends upon stepping on the rung right below it, right? You can't just skip all the way ahead to the top. So you start on the first rung of the ladder, which is A1, right, first term. From the first rung, you have to move to rung 2. So A2, right, second term, is first term plus a step up. Same idea for the third rung, right? You start with the second and do a step up. So this is the idea that like the Fibonacci sequence, so a term is, right, the previous term plus like 2 terms ago, right? So you could say previous term plus 2 terms ago if you want to say it like that, right? The last 2 terms get added together. So it's like if you want the 5th term for the Fibonacci sequence, you would have to add the 3rd and the 4th, right? That's kind of like if we go back here, if I erase my colors, this is the 1st, 2nd, 3rd, 4th, 5th. To get the 5th term, I have to add the 3rd and the 4th. The 3rd is going to be the 2, and the 4th is going to be the 3. So the 2 and the 3 combine to be the 5. So that's the idea. We're just calling these A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, following that same notation. Go back to here for a sec. Oops, sorry about that. So the idea is that if you're on the nth rung, you have to have stepped on the n minus first rung. So this nth rung, you need the rung right before it. That's what this means, the previous one. And then you add that step up. So the big idea I want you guys to focus on here is this guy here. So all you really want to take away from the ladder is the idea of the step up. Like that's probably the most crucial thing. So I'm going to highlight. This is probably the most crucial thing to understand, the step up. This is a nice example. And then we're going to focus on this. So in thinking about the Fibonacci sequence, right, to get the new term, I'm going to kind of do some highlights here. The nth term is kind of representing this in words. We need to have the previous term, which is the n minus 1, 1 before, and then 2 terms ago, that's going to serve as this guy here. I'm just going to take that away to get the color coding looking nice. And a nice example of that is the 5th term example that we looked at. So an example, we looked at how the 5th term was the 4th term plus the 3rd term. I'm just going to write it this way because it has like the one right before and the one 2 terms ago. Notice if you look at the notation there, this notation is the part that trips up students normally. If I'm talking about the n minus 2 term, that means I'm saying 2 terms before n. The thinking is that if you have the nth term, right, if I kind of start with the n in the middle, the next one is n plus 1. The one before is n take away 1. The one before that was n take away 2. Just like going the other way is n plus 2. So thinking about this, right, to get the nth term, you need to add the one right before it and the one 2 before. So I'm going to keep referencing back these ideas in the practice problem. There's one practice problem just to kind of feel out this idea. And I'm just going to leave that stuff at the top of the screen as we talk through. So here's what a recursively defined sequence might look like. Right? We're going to look at a different pattern than the Fibonacci pattern. This one tells us that the first term is 5. So I say, okay, first term is 5. This rule is telling us that the nth term is going to be 2 times the previous term minus 3. So I'm going to say next term, or I'll just call it term. I think I called it term before. So a term is 2 times previous term, take away 3. So that's the rule we're going to follow. And notice, right, if green is our current term, right, one term before that would be the n take away 1 term if we kind of use that box as a reference. So I'm just going to kind of write out some examples to kind of see what the sequence will be. We want the first 4 terms, right? So thinking through, 2 times previous term, 2 times 5, take away 3. The next term is going to be a 7. So that's going to be term 2. If you want to write this out using the notation, it's going to be a little bit more complicated. The idea is if I'm looking for the second term, that's 2 times 2 take away 1, minus 3, sorry about that, which kind of simplifies to this. So second term is 2 times first term minus 3. This part here is what will trip up students sometimes. So I prefer just to think of it in terms of this. Double the previous term, subtract 3. That's kind of the easiest way to do it. So doubling this number of 7 gives me 14. 14 take away 3 is 11. Doubling this number is 22, right? And then we're going to take away 3, which will give us a 19. And those are the first 4 terms, right, that we have figured out. So that's all they asked us to find. So the big ideas here are just kind of that notation and how we read previous term and 2 terms ago, right? So current term, previous term, 2 terms ago, next term, 2 terms later. Okay, so keep that in mind. Make sure you've written out kind of this idea that's on the screen. This is a nice snapshot of the big idea of a recursive sequence. Now, you'll notice, just kind of a closing thought. This one, in order to keep writing it, right, I always need to know the previous term. So if I asked you, if I said, figure out what the 100th term is, right, you would need to know the 99th term, which means you're going to have to kind of keep going and building it up to get there. Think about the ladder. If I ask you for that 100th term, you have to do all the rungs below. So because of that, it's not as useful as the rules that we've seen previously, where I can just plug in any number, right, for my specific term, and I don't need to have any previous ideas to get that term. So keep that in mind. This is not the most useful way to write sequences, but it is really important to expose you to other ways that we can talk about a rule.